This video illustrates the modeling of a lithium-ion battery in a plug-in electric vehicle in PowertrainLive. The full vehicle battery is represented as multiple individual cells in series and parallel. Each individual battery cell is represented as a first-order RC circuit. This representation is shown on the screen. This means that there is an OCV, which is the open circuit voltage, an R0, an R1, and C1 for each cell. Each of these parameters are a function of the state of charge and temperature of the battery cell. So, to represent the battery in PowertrainLive, you will input the following: number of cells in series, number of cells in parallel, the OCV as a function of the SOC and battery cell temperature, and similarly the R0, R1, and C1 as a function of battery cell and temperature. These performance parameters are provided by the battery supplier or generated by a battery chemistry program or perhaps extracted from battery performance test data. CSEG has experience in generating battery performance characteristics from test data and has a library of battery performance characteristics of production hybrid and electric vehicles. You may contact us for more information on this. Since these parameters are dependent on the battery's temperature, you will also input the temperature profile in drive cycle. You can also use a separate battery thermal model to calculate the battery temperature profile or enter a constant value. Shown here are battery performance characteristics of a popular plug-in vehicle. With these performance characteristics, let's run the full vehicle model for the UDDS drive cycle to see what the typical results look like. First, you will be able to see a summary of total energy consumed by the vehicle. Then, within the battery subsystem, you will be able to see detailed performance parameters of the battery, such as the battery's current draw, heat rejection, state of charge, and terminal voltage. Battery heat rejection is very commonly used as an input into a battery thermal system model for co-simulation with PowertrainLive. You can perform studies with this vehicle model to understand the full vehicle impact of component performance. Let's investigate the impact of battery resistance change. We enter new resistance curves into the battery model that we received from the battery supplier that is being considered for this vehicle. Then, we run the vehicle model for the full drive cycle. We can see the full drive cycle battery power consumption change in the summary section. We can also overlay the battery parameters for the two batteries to understand the impact. For more technical support videos, please look in the Technical Help section of PowertrainLive.com.